Okay, here's the factoring review that we're going to do in Chapter 6, Section 5. We're going to do reviewing factoring out the GCF, which is greatest common factor, factoring the MA method, which stands for multiply add, factoring by grouping, and then factoring the difference of squares. And we have done all of those. Factoring out the GCF, two questions you need to ask yourself. Do all the terms within the expression have a GCF? And when I have factored that GCF out, am I done? When the problem is finished and you have factored. Take a look at the problem A. 35x to the third, y to the fourth, minus 60x to the fourth y. First, you take a look at the numbers 35 and 60, any numbers that you have throughout the problem. If you're not familiar with factoring numbers, what factors go into them, this is something you have to practice. There is a tool on the calculator that helps you with that. If you have an Inspire, if you're in class and are able to use Inspire, other than that, you have to know your multiplication tables, or you need a chart that lets you do multiplication tables, or you need to practice. Come in for tutoring and let's practice that. But what you do is 35 is 5 times 7. 60 is 5 times 12. What do they have in common? Oh, a 5. 5 times 7. 5 times 12. That's their GCF. So 5 goes into both of them. And then we look at the variables. X to the third. We have x to the fourth. We must have an x to the third in there. So we'll take out x to the third. We have y to the fourth. All we have is y over here. So we can take out y. And when we take that out, as in divide that out, we're asking ourselves, we're setting up an answer that looks like distributive property. So 5 times what is going to get us back to that 35. That would be how you would check yourself. So 5 times 7 is 35. X to the third times what is going to get us back to the x to the third? Well, by nothing. We don't need to multiply x to the third by anything else to get x to the third. So there is no x within the answer inside those parentheses. Y times what is going to get us to y to the fourth? Y times y to the third is y to the fourth. And then we're subtracting. We have subtraction that we carry down. 5 times what is 60, which is 12. And then x to the third times x is x to the fourth. Y times what is going to give us y? We need no y. Y divided into y, it's canceled out. We have no y left in that answer. So that is your GCF factoring. And if you take a look at problem B, I have this there to just demonstrate that not every GCF problem has 2 terms. You have a GCF problem here that has 4 terms. They all have x, y as their common GCF. You don't always have to have a number other than 1. 1 may be the only thing. They have variables in common. That's a GCF. So this is demonstrating a GCF problem factoring. Let's look here at this is factoring MA. So you've got you'll take a look at it. You have the ax squared plus bx plus c. This is where the MA comes in, where you are going to multiply, looking at the dotted line, the a times c. It's not the x squared. The a is in front of the x squared. The c is that last term, which has no variable. It's just a constant. We multiply those together. So this is kind of all the scratch work over here and behind my head. We multiply those two together. We get a negative 18. What are those factors? So we can list all these factors or begin thinking about them. If you come to them first, fantastic. If you don't, you can list them all. I know I have done that religiously myself, just to make sure that I get it correct. So you have these factors that multiply up to this negative 18, which came from a times c. You need to add them up at that point to see if you get the middle number. They're linked. It's a pattern. The numbers have to fit together. All these numbers in this problem. If you miss that, you have to practice and you need to come to tutoring. We have done this before. This is from chapter 5. This is now on you, and you need to put some more work into this. So we take these factors right here and we add them up, and the scratch work is behind my head. So 1 and negative 18, that's negative 17, definitely not 7. Negative 1 and 18, that's positive 17, definitely not 7. 2 and negative 9, that's negative 7, nope. Negative 2 and 9, that's 7. Those are the factors that I need. And so there's the step where we rewrite that and 9 minus 2, 9x minus 2x, that is my 7x. That is another way of writing 7x. So that 7x is there. It's just in 2 terms. So here's the second step, where it's broken up into 4 terms rather than the 3 terms that it began with. And at that point, we have this split into our first 2 terms. What is their GCF? That's where this 3x comes from. 3x is the GCF of 6x squared and 9x. We've done this before. And I'm going back to that factoring GCF, which we just practiced. So if I divide out 3x out of 6x squared and 9x, I have 2x plus 3, which is left over. What is the GCF of negative 2x and negative 3? It is negative 1, so I have 2x plus 3. Remember at this point, the check on this step is what I have inside the parentheses should match. If you have done everything right, these should match. Just don't make them match. Double check. Is negative 1 in fact the GCF? Yes, it is in fact the GCF. If you divide out negative 1, does it change these signs? Yes, it does. We don't just make it do that. It really does mathematically work that it changes these signs, and it does in fact divide into negative 2 and negative 3, so that you have 2x plus 3 and 2x plus 3 here. You don't just wave your hand and make it work just because it's supposed to. It mathematically works out. So you factor again 2x plus 3 out because it's in common. If you take that out, what is left in front? The 3x minus 1, and that is the other factor here, and your answer is finished. And so that is MA. And here's a problem that we can try. Grouping. Once you have MA down, you got grouping. So grouping is all the parts of MA after that A times C and what are those factors that I need to rewrite. It is a problem that has 4 terms generally. For the most part, we can get into bigger grouping ones. And you ask yourself, does every term have the same GCF or shared GCF? No. So can I split it? Can I group things up? When we look at these first 2, well, yeah, they have GCF. 6m goes into this problem in the first 2 terms. So when I divide out 6m, what do I have left? Oh, well, just n, and then 3. Okay, what about the last 2? What divides into them? Well, it looks like 1. Maybe I can change the sign if I divide out negative 1, and I have n plus 3 left. Oh, stuff matches. I have n plus 3. In front, I have 6m minus 1, and I'm done. And those are the things that we had just done in MA. So grouping, you have totally tackled and mastered once you are good with MA. You remember we had done this in chapter 5. Difference of squares. This was really nice. If you know these perfect square numbers, and it would be good if you do not know perfect squares to make yourself a list. Go do that. And again, this is another one of those things, if you don't know this by now, you definitely need to go make a list right now. So here's perfect squares. Difference of squares, you will always have 2 terms. 2 terms only. And we had done these, and these are the nice ones where you will have, it begins with 2 terms, you will have 2 factors, 2 binomials as answers, and in those 2 binomials, you'll repeat the same terms. And what they are is the square roots of what you had in your problem. So the square root of r squared, what did I square to get r squared? Oh, r. I had to square r to get r squared. So that's my first term. What did I have to square to get 49? 7. So 7 is going to go in here. And you have an addition and you have a subtraction factor. And that's your answer. The only thing that can be complicated is if one of your terms is more than just a variable or more than just a number. It's a combination of the 2. So in this first term, you not only have 100, but you have m to the 8th power. So you have to do that together. So the square root of 100 is 10. And what do you square to get m to the 8th? Well, you have to have 2 of exactly the same thing. So m to the 4th, m to the 4th gives you m to the 8th. So 10m to the 4th is your first term in both of these factors. And then what do you square to get 9? 3. And so 3 is in both of those factors. And you need to add those 2 factors, and you need to subtract those 2 terms in the 2 factors. And so you can practice more of that. And that is the factoring review, and we will learn a new pattern to round all of this out.